Now, some of these will actually be familiar methods that we have used with our quadratic equations in the last one. Obviously, we will not be able to use the quadratic formula because quadratic formulas only work on second degree polynomials, and we're getting into higher degree polynomials here. But factoring process, our zero factor property, all of those concepts will obviously still hold in this case. So of course they're saying if we can factor a higher degree polynomial, we can set each factor equal to 0 and then of course solve our resulting equation. This is often the easiest method for solving higher degree polynomial equations. So let's go ahead and take a look at our example here. So what's happening here is you've got x to the third minus 2x squared plus 5x minus 10 equal to 0, and they're asking us to solve this by factoring. Do we have any idea what we need to use as far as factoring goes in this case? No? Yes, you are actually going to factor them by grouping. So we will go ahead and group the first two terms, and we will group the last two terms. So let's see how we can actually go about solving this guy. So we've got x to the third power minus 2x squared plus 5x minus 10 0. Group the first two terms, group your last two terms. So between x to the third and 2x squared, what are we seeing as a common factor here? X squared, yeah, because I've got 3 of them here, 2 of them here, so I can take outside the x squared. Your x, is that what you were going to say? Yeah? So if I'm taking 2 out, I'm left with 1 over here, right? So just an x left behind minus what's happening from the 2x squared. What do I have left? 2. Just the 2, yeah, because we already brought the x squared outside. Just the 2, and of course we keep the same sign in the parentheses that we had between those two numbers. Now, we actually use that same idea here. So I have a plus sign here. I'm actually going to keep that plus sign in between my terms. Now, between 5x and 10, what's our greatest common factor? 5, yeah, very good. So I'll take the 5 outside. So from 5x, what am I left with?
X.
Just the x. Keep the minus again. 5 goes into 10 twice. Now, I had kind of mentioned this before. If we do this step correctly, both our parentheses should match, right? So I should have x minus 2 and x minus 2. We'll go ahead and combine them together into one single factor.
They should always match.
They should always match, yes. If they don't match, we did something wrong.
Okay.
Okay? And then, of course, take whatever you have on the outside and put them in one set of parentheses. So that's going to be our x squared plus 5 from the outside. We'll go ahead and make those into a factor. Now, this is where your zero factor property kicks in now. Go ahead.
How did you get to that third line again? Sorry.
Oh, so we took our x minus 2, put it together, and then these terms on the outside. So the x squared plus 5 form your second factor. Essentially, what's happening here is we're factoring it again, because now I'm saying between this term here, x minus 2, and between this term here, x minus 2 is common. So I'm actually factoring that out again, and then whatever is left behind goes into my second set of parentheses. So do you remember what we do with the zero factor property? What do we do, Amy?
So you set each set of parentheses to 0.
Yeah, so we'll take each one of these and set them equal to 0. So I've got x minus 2 equals 0, or our x squared plus 5 equal to 0. So what do you think those two answers should be? Yes. True. Yeah, so this one, of course, just go ahead and move that 2 to the other side. You get x equals 2. What happens with the x squared plus 5?
Does it become x equals 5i?
Yes, you're actually going to end up getting imaginary answers here because we will start by moving that 5 to the other side, which will make it negative. And you get x squared equals negative 5. Now, of course, to get rid of the x squared, we need square root, right? And that's where that I term is actually coming from. So to get rid of that x squared, we'll go ahead and take a square root on both sides. What happens when we take a square root? Come on, you couldn't have forgotten. Sorry? Before that, before I cancel out my square with my my square root. You got to remember this, people, very, very essential. Anytime you take a square root, you're going to get one positive root, one negative root. Okay? So your square and square root cancel out, giving you x equals plus or minus. Remember, we did this last time. If you have square root of negative 5, that's the same thing as negative 1 times 5. The square root of negative 1 will become I. The 5 cannot be simplified, so it will continue to stay inside the radical. Okay, so this is our scratch work here on the side. So this guy will actually become plus or minus I square root of 5. Now, just to kind of go back to the beginning, this is a third degree polynomial, which tells me at most I should have 3 solutions to this equation. Now, if there's repetition, then you can have just 2 or 1 or maybe none. But at most we should have 3, and if you look, we do have 3 answers here. So our solution set is going to be negative I square root of 5, positive I square root of 5. So that's the 2 solutions coming from here. And then, of course, we've got x equals 2. So we've got our 3 solutions to the equation. Questions on number 1? Solving by factoring. Yes.
Is the reason there's 3 answers in the solution set because the first like degree is 3, or is that not right?
Yeah, so whatever is the highest degree of your polynomial, that's how many possible solutions you can have. So it's always dependent on, so if this was like a 5th degree polynomial, then technically we should have 5 solutions to it, which is what I believe our example 2 is. It's a 5th degree. Now remember, you can have repetition, right? So I can have, if this was, okay, that was weird. If I did not have to take a square root here, I could potentially have had the same answer just repeating twice, which is what we actually call multiplicity, and we'll be talking about that chapter 3, I think. But so sometimes you may not have a list of all 3 or all 5, but that just means you may have repetition, which is the multiplicity. Okay? All right, very good. Anybody else have a question on this one? Okay, let's look at our next example. Now, what do you think should be the first part that we need to do here to solve number 2? Yeah, very nice. Get them on the same side. So I would actually go ahead and subtract that 27x squared and move it over to the x to the 5th, so that you will have x to the 5th minus 27x squared equals 0. Now what can we do to solve that. You've got x to the 5th minus 27 x squared.
Can you factor it out?
Yeah, that's where I would start. So what can we factor from these two terms?
X squared.
X squared, yeah, I've got 5 of them here, I've got 2 of them here. Bring out that x squared, which will leave me behind with, yeah, very good. X to the 3rd minus 27 equal to 0. What can I do next? Do I go to my zero factor property?
27 don't you take, like, don't you have to do something like with the cube?
We'll need to simplify that. But instead of factoring, I would actually use the zero factor property, because if you try to factor this, then you got to remember what the rule is. Does anybody remember what the rule is?
Oh, isn't it a minus b equals a plus, or a squared plus ab minus b squared?
Okay, tell me that one more time.
A minus b, and that one, and then times a squared plus ab, yeah, plus b squared.
Plus b squared. I am very impressed. You may be the first one in all of my life of teaching who actually knows that rule. So if you know the rule, you can use that to factor that x cubed minus 27, but if you don't, and even if you do, make your life easier. Take each one of these factors, set it equal to 0. And of course, to get rid of a square, we'll use square root. And anytime you use a square root, you have to remember about the positive and negative root. Which 0 is actually a pretty uncomplicated number. So what is square root of 0 with a plus or minus? 0, because 0 does not take a sign, right? So you're actually going to get technically just a 0 out of it, but since this is the second degree and this is kind of what I was talking about, that just tells me that 0 is repeating twice because it came from this second degree portion of our equation. So we're not really quite ready to talk about multiplicity, but I will go ahead and write it down. So we have a multiplicity of 2 on the 0, which means it's actually occurring twice in our solution set. Now, coming back to this side of our problem, you want to start out by adding that 27, moving it to the other side. Pretty much doing the same thing that we did with the square term here, but with the cube. And you are going to get x cubed equals 27. If I'm using a square root to get rid of a square, what should I use for a cube?
Cube root.
You use a cube root, yeah. So that's going to be cube root. And basically you put a little 3 on that lip of your radical, and cube root of 27. Cube roots do not need a positive and a negative sign, because cube root, if it's a positive number, your root is positive. If it's a negative number, your root is negative. So unlike the square where we put a plus or a minus, you don't have to do that with the cube. So the cube and the cube root cancel each other out, giving you x. Now the question is, what number multiplied into itself 3 times gives you 27? And that's going to be the number 3, right? 3 times 3 is 9. 9 times 3 is 27. And again, in terms of multiplicity, since this is coming from a cube, that means this number is actually appearing 3 times. So that's multiplicity of 3. But you know, when we write our solution set, it's just going to be writing those numbers once. You don't have to write the repetition. you know, that's why we use the terminology that at most you will have 5 solutions. Technically, I have 5 solutions, but when I write it down, it just looks like I have 2, right? And that's because of that multiplicity. But that's pretty much what you end up doing here. This one actually is not that bad, because once we got that x squared out, we got our 2 factors. We take each factor, set it equal to 0, and you solve each one of them. Here, we ended up getting x squared equals 0, which only gave us x equals 0 when we got rid of the square. And with the cube, you basically took cube roots on both sides, and you ended up getting x equals 3. Okay? Does anybody have questions on number 2? Spencer?
I think like, if we didn't know that other formula, I don't really want to take the extra time to do it again, but if we didn't know that formula, what would be another way?
It would get ugly.
Okay.
Because if you tried factoring this, okay, so let's see here. We're talking in terms of, and I'll just show you the cube part, so we're not doing the whole thing again. We were at this stage, right? So when you factor it, this would be x to the third. Let's write it out like this first, and then I'll factor it. So it'll be x minus 3, right? Just kind of following our rule over here. This will be x squared plus 3 times x plus 3 times 3, which would be 9. And then we would need to factor this guy out, which would not be a very happy factor. But what can we do? Because you will still use the zero factor property here. You take each one of these, set them equal to 0. This guy, of course, will give us x equals 3. Can I factor this? Factors of 9 that will add up to give me 3? No, right? Because 9 is going to be 9 times 1 or 3 times 3, and none of those additions or subtractions will give us a 3. So where does that take us? Either completing the square,
Or
quadratic formula, right?
Yes.
Or quadratic formula. Does anybody know what kind of answer we're going to get from a quadratic formula here? Are we seeing anything inside the radical? It's going to be negative. You're actually going to get imaginary numbers from this part. What is 4 times 9?
36.
So 9 minus 36 will be negative 27. Yeah, you're actually going to get negative 27. 27, is that a perfect square? No, it's a perfect cube, but not a perfect square. So you're not even going to get a nice and clean answer. You are going to get plus or minus. How can we simplify square root of 27? 9 times 3, right? So 9 will come outside as 3. The negative will come outside as I. And the 3 will continue to stay behind. And so you can see the only answer I'm actually technically able to use is the x equals 3. These guys are going to be imaginary numbers. So that's the reason why I would say make your life easier and don't go the factoring route, because it does lead you, I don't know, down the rabbit hole. So it's easier to do it that way. Okay. Anybody else have questions? So this is really the way I would go, is to set each one of them equal to 0 and use a square root and a cube root to help you out. Okay. All right, so that was using factoring to solve a higher degree polynomial. Now let's see what we can do with equations that actually have square roots in them. So they're saying, obviously, the idea of getting rid of a square root is to try and square both sides of your equation. But when we try and do this, that actually means you can end up with extraneous answers, answers that are not going to satisfy your original equation. Because the moment I square both sides of my equation, I'm actually changing it, right? Because I'm introducing an extra piece in there, which was not already part of my original equation. So what happens when we're solving problems like these is you always have to check for that extraneous root and discard it if it shows up in your solution set. So the answers that we get from solving these equations, we didn't have to worry about that in these first two examples. We didn't need to check our answer because we knew what we did was going to work for us as long as our math was good. But with these equations, we have to check our answer and kick out anything that's not satisfying your original equation. So they're saying start by isolating your radical. Make sure there's only one on each side of your equation. We will square both sides to get rid of the square root. They're saying isolate or separate any remaining radicals, and you'll actually see an example when that happens. And this is the important one, check all solutions, because you will end up with extraneous one. So let's actually start with this example here. Now remember, our step one is to get all the radicals isolated, which means you want to go ahead and move that 12 to the other side. So the first thing we're going to do is move that 12 to the other side, get our square root of x equals x minus 12. Okay. Now, once you get it to that part, you can obviously get rid of its square root. So we were at square root of x equals x minus 12. Now this is where we're ready to square both sides because we isolated our radical. So now I will go ahead and square both sides of my equation. On the left-hand side, the square root and the square will actually cancel each other out, giving us just an x. What are we going to do on the right-hand side? In what sense?
Like, you'll distribute the square onto the x and the -12.
No.
You square the whole equation as a whole.
Yeah, because x minus 12 to the second power means you are doing x minus 12 times x minus 12, which means I need to FOIL my right hand side. Okay, be very, very careful because this will not get you to the right answer, because what's going to happen if I just square my x term and my 12, I'm going to miss my middle terms, right? So I got to remember that I'm actually going to FOIL my right hand side. So that will end up giving me x times x will be x squared minus 12x minus 12x plus 12 times 12,
144.
144. When we clean this up, we will have x squared minus 24x plus 144 on the right hand side. And what should I do next? Do you know, Jose?
I'll get the x on the other side.
Yeah, you want to get 0 on one side, get that x to the other side. So we're going to move this x, subtract it, and combine it with the middle term. Trey, is that what you said?
Yeah.
Yeah? All right, 0 on this side, and I will end up getting what?
Be negative 25x
Yeah, negative 25x. So x squared minus 25x plus 144. And can I actually factor that? Because if not factor, what else can I use? The quadratic formula. All right, let me see what you guys come up with. Because I'm going to try and see if I can factor this. So either try factoring or try quadratic formula, and let's see what answer you come up with. Yeah, it can actually be factored. Okay, so if you are using the quadratic formula, I'm actually going to break it up into two parts. Quadratic formula, technically this is our A, which will be just 1 in this case. This is our B, which is negative 25. C is 144. So in your quadratic, negative B plus or minus B squared minus 4AC over 2A. You should have negative of negative 25 plus or minus. We'll again have negative 25 squared minus 4 times A. Again, remember your A is 1 and C is 144. Oh. Everything divided by 2 times 1, which is just 2. So positive 25 plus or minus 25 squared will be 625. What is 4 times 144? 576. Alrighty, divided by 2. Can you tell me what that subtraction will be? 49. Okay. Yeah, because you're just shy of 50 here. So, and I still write 50. 49, which is nice because 49 is a perfect square. You are going to get plus or minus 7, which will lead you into 32 over 2, right? When I add, which will be 16, or subtract 7 will be what, 18 over 2, which is where the 9 is coming from. So you're coming up with 2 solutions. 16 or 9, and you got to check which one is going to be the extraneous ones. Now, if you would have had to try factoring, because that's actually the route I would take, these guys would factor into x minus 16, and of course we know the answers at this point, x minus 9, because 16 times 9 negatives will end up giving us positive 144. When I add negative 16 with negative 9, I get a positive, a negative 25. So again, I would end up getting 16 or 9 as my two solutions. Now checking for your extraneous, as I was explaining to Raylan here, stop doing that. You actually just put it back into the original equation. So let's see if we can make it work here. So our original equation is square root of x plus 12 equals x. Try it with both the numbers. So I would have square root of 16 plus 12 equals 16. What is square root of 16? So you would have 4 plus 12, which will of course give us, I have a true statement, which means 16 works in our original equation. We can keep it. Now, repeat the same process with the 9. So that's going to be square root of 9, and you can kind of see it's not going to work for 9 right away. Because when I take square root of 9, what do I get? 3, and 3 plus 12 does not give us 9. So that's a false statement, which means I cannot use x equals 9. I can, however, use x equals 16. So our solution set is just one number. So that's kind of what they mean by checking for your extraneous roots, because not all the numbers will work in the original equation. Some of them, both might work, one might not work, or for that matter, both might not work. It just depends on the problem itself.
So when you're doing the factoring, does that mean 9 does work for factoring, or?
No, that would just help us, stop doing that. That would just help us in coming up with the answers instead of using the quadratic formula. You're using factoring, because if you can factor it and the factoring doesn't take that long, it actually does go faster to factor. I am actually not a big fan of quadratic formula unless I absolutely have to, because I just feel like there are so many steps involved in it. So by personal choice, I actually prefer to go the factoring route, but you know, sometimes it can take multiple tries before you find that combination of numbers that will work, and sometimes you may not get that at all. So it's just a personal preference, whatever you prefer. But you can see we would still get 16 and 9 and 16 and 9. So I would still have to end up checking my answers no matter what. Okay? What do you guys think of the next example? So remember, our first step is to isolate our square roots, get them on one side. So that means I actually need to move that square root of x and get it to the other side. This one, if you don't think you have enough space, get a piece of paper out. It does take quite a few steps to go through this one. So we will start by adding that square root of x, moving it to the other side. And we will have square root of 3x minus 2 equals square root of x, and then outside you have the plus 2. This is where we're at right now. To again get rid of the square roots, we need to use square, but this is actually the one where we'll need to clean up our radical one more time. So we'll start by taking our square on both sides of our equation. Okay. Your square root and square on the left-hand side will cancel out. leaving us behind with just 3x minus 2. This guy is pretty much the same thing that happened in the previous example, so we need to FOIL this side. So you're actually looking at square root of x plus 2 multiplied with itself.
How come that square root doesn't cancel out that
You cannot individually distribute
when
them.
they're separate? So since those are all under there, you can.
Since this entire thing was under a square root, it was easy to cancel. So that's why we need to FOIL this. And when you FOIL this, you'll see we'll have a radical actually left behind. So you start by multiplying your first terms. So square root of x times square root of x, what will that give you? Because technically I should have square root of x to the second power, right? Because I'm multiplying the same term with itself. So this is where actually my square root and square would cancel out, giving me x, and that's just from that f, the first that I multiplied. But when I do the outer, which is these two guys, I will end up having 2 times square root of x, and that's the square root that stays. Yeah, this one does get pretty involved. The I, the inner terms, is again going to be 2 times square root of x, and then 2 times 2 for the last terms will give us the 4. It is not a happy number at this point, just because that radical does carry over, and we'll need to clean it up. Again, if you actually go back and look at the steps for this on page 1, it's telling you isolate or separate any remaining radicals, and you will need to square again, which was step 3. So this is kind of that problem that we're talking about, where you will have a radical left over. All right, so for my first terms, I multiplied the square root of x with the square root of x. I got square root of x to the second power, so this is where these two cancel each other out, just leaving us with the x. You will be able to add your middle terms here, which will be 2 plus 2, which is 4 square root of x plus 4. So this is what your right-hand side cleans up into, and this is all just scratch work. So you end up getting x plus 4 times square root of x plus 4. This is what your right-hand side will clean up into. Our goal at this point is to isolate that remaining square root of x. Okay? Okay, so before I actually move forward, I just want to make sure everybody's with me at this point. We started out by taking our square root of x, moved it to the right-hand side, so that I could mainly isolate my square root of 3x minus 2. And then, of course, I had that extra plus 2 at the end. When I took a square on both sides of my equation, since these guys were all inside the same radical, my square and square root canceled each other out, giving us the 3x minus 2 from there. On the right-hand side, however, I have a binomial term, square root of x, and then plus 2 on the outside to the second power. That's why I needed to FOIL it. When I FOIL it, my first term actually will come out to be x. The middle terms add up to 4 square root of x, and then, of course, the last term comes out to be plus 4. At this stage, I am trying to get rid of all these extra terms and just leave my radical term at this point. So I'm subtracting my x from the 3x. And I'm actually also going to subtract my 4 from the 2 here. So cancel these guys out. When I combine these terms, I will end up getting 3 minus 1, which is 2x, negative 2 minus 4, negative 6, and now I am left with 4 square root of x. What should I do at this point?
Divide by 4 to isolate the
Divide by 4. If you don't want to mess around with the fraction, you don't have to divide by 4, because 6 divided by 4 will actually give you a fraction, right? It's not going to clean up. So it's up to you how you want to do it. Do we want to divide by 4? Or Or do we not want to deal with fractions? We don't want to deal with fractions? Okay, that's fine. We can, again, go ahead and square both sides because, again, to get rid of the square root, we need a square. Foil your left-hand side. Square your right-hand side. So again, let me show you what happens on the right. We've got 4 square root of x to the second power, right? There is no plus or minus sign between the 4 and the square root of x, is there? No, so that's telling me I'm multiplying. This is where I can actually distribute my exponent. So this is where I can actually distribute it and get 4 to the second power and square root of x to the second power. As long as there is no plus or minus sign between those terms, you can distribute your exponent. 4 squared, of course, will give us 16. The square and the square root here will cancel each other out, giving you 16x on the right-hand side. You will need to FOIL the left-hand side again. So that's going to be 2x minus 6 multiplied with 2x minus 6. I'll give you guys about a couple seconds here to go ahead and do that FOIL and tell me what numbers do you come up with.
I got 4x squared minus 24x plus 36.
Very good, yes. 4x squared minus 24x plus 36. What should we do next?
16.
Yeah, go ahead and subtract that 16x. What is negative 24 minus 16? Yeah, negative 40x plus u plus 36. Again, you can see we actually ended up getting a quadratic term again, second degree polynomial. So you can try factoring, simplifying, quadratic formula, whatever makes it seem easy. Can you see anything common between all 4 of those terms? Yeah, you can actually divide everything by 4 and simplify your numbers. So 4 goes into itself once, that will give us x squared. 4 goes into 40 10 times, so you will get negative 10x, and 4 goes into 36 9 times. Of course, 0 divided by 4 is 0. Factor this. What?
Yes, yeah.
Yeah, 9 times 1. Now, if you want to use quadratic formula, trust me, I have nothing against him. I'm just a lazy person who does not like to write too much. So if you want to use the quadratic formula, that's fine. You will still get the same answers. I am just going to use factoring. So this will break into x minus 9 and x minus 1. Again, remember, the idea is the numbers should multiply to give us positive 9 and add up to give us negative 10. So that's going to be the combination of negative 9 and negative 1. You multiply, you get positive 9, you add, you get negative 10. So this will actually give me 2 answers again. Set each one of them to 0, just like we did previously with the 0 factor property. You'll get x equals positive 9 or x equals positive 1, and then we still got to check for our extraneous solutions and see what happens. Where's my original equation? So we were at square root of 3x minus 2 minus square root of x equals 2. All right, I guess I'm going to start with the 9. 3 times 9 but minus 2 plus u square root of 9. 3 times 9 will be, what's 3 times 9? 27 minus 2?
25.
25. So square root of 25 will be 5. Square root of 9?
3.
Alrighty, so it looks like we're getting 2 equals 2. That's a true statement, which means x equals 9. You are good to go. Alright, let's do the same thing with x equals 1. That will be 3 times 1 minus 2 minus square root of 1 equals 2. Is he looking like something that might work? No, because 3 times 1 is of course 3. 3 minus 2 is 1. And technically you're subtracting the same quantity, right? Which is of course a false statement, which means you don't work. So again, in this case, we only get one answer as our solution set, and that's going to be number 9. So you can kind of see why checking is such an important part of these equations, because this is where you have radicals that you are trying to get rid of, and especially because you have square roots in there. Cube root is actually a pretty friendly root. Square root, they try to act up a little. The square roots, you got to remember to check for your extraneous answers. Yes? All right. Any questions on number 4? And I know it's a long, long problem. To make your life easy, I will not put it on the exam. Because I don't want you to spend 10 minutes doing one problem, and in 10 minutes you can technically do 2 problems. Okay? So 4 will not be on the exam, but obviously you should expect to see at least something like 3 with one of them showing up. Man, I can't believe we didn't even make it to 1.6.
Water writing.
Okay.